Hello, everybody, and welcome to lesson 3 of Ava, the WhatsApp agent. In this lesson, we are going to cover a couple of things that I have already here written. So first of all, you're going to check or you're going to understand how Ava uses her memory, both the short-term and the long-term memory. Then I'm going to introduce you to the concept of RAG. I think one of the most important concepts in Gen AI applications, and I think it's used in most applications in one way or another. As part of this RAG, we are going to explain you what is a vector database, and I'm going to explain you all the different database providers, so the vector database providers that there are, and why we chose to work with Qdrant. Then we're going to dig deep into the code. Actually, we're going to understand how the short-term memory is implemented using MySQL or SQLite, and also how the long-term memory is implemented using Qdrant. And finally, I'm going to show you how you can set up your own instance of Qdrant Cloud, because actually they have a free tier that allows you to create your own free cluster using Google Cloud. Okay, so zooming in, we have the first diagram that Miguel has prepared. And as always, it's looking beautiful. This is a really cool diagram because it shows both the short-term and the long-term memory in the same kind of like picture. And I think you will understand it very, very well. So let's start by looking at the short-term memory that we have represented here on the left. For storing this short-term memory, we are using SQLite, and everything is running directly in the Docker instance or in the local machine. And what this short-term memory stores is actually the graph state that we already reviewed in the previous lesson. So if you haven't looked that video, you should go and look for lesson 2. But essentially what we have is a set of parameters that we have selected for our application. And those are the summary of the conversation until that point, the workflow that has been selected by the router, either conversation, an image, or an audio, the audio buffer itself, the image path itself as well, the current activity that Ava might be doing, and the memory context, which refers to those memories that we retrieve from the long-term database. Plus, of course, all those recent messages of the conversation that you're having right now with Ava. A conversation that I want to review with you because I think it reflects very, very well how we extract those relevant memories. And let me come back quickly to the diagram of the previous lesson. So this, the graph diagram, right, in which we represented those nodes and edges that conform our brain or our graph or Ava's brain. And as you can see here, the first node that we have is just the memory extraction, right? So just remember that, and let's come back to the memory diagram. But everything will be super, super clear once in a couple of minutes we review the code. Okay, back to the memory diagram, and now let's pay attention to the right side part of this diagram, so the long-term memory that we implement with Qdrant. And by looking at this, we're going to start already understanding how we extract those relevant memories. So let's start from the top, right? So we have Ava just saying, hello, I'm Ava. And now Miguel will be saying, hey, I'm Miguel, nice to meet you. So what starts happening here is that Ava, or the system that we have built, or Ava's brain, will process each of the messages that Miguel sends or that the user sends and understand if there is something relevant, so something that is special to this user, right? Something that, for example, denotes a name, or where is he's from, or what is his profession, or what does he like to do, or what is he doing right now in the moment. So this will probably remind you of how ChatGPT more or less remembers the conversations that you have had with it. And right, like probably in ChatGPT, you have seen that when you tell something important to ChatGPT, for example, I'm building this cool machine learning or artificial intelligence project called Ava, blah, 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 blah. And now probably you will see, or I will see my messages something like memory updated. And what ChatGPT is doing is more or less what we are seeing here. So let's look at what we have here. So Ava will maybe like just have a normal conversation with you, and maybe like she will ask you, hey, where are you from? And Miguel will say, I'm Spanish. So this means that Ava will understand, okay, Spanish, this is relevant. I'm going to save this in my long-term memory. Same thing, right? Like the profession, so machine learning engineer. So you would have a kind of like a completely normal conversation with Ava, but in the background, Ava will be saving those key aspects about yourself. And what Miguel has put in this diagram nicely with the string or that piece of text that Ava will get from the message, and then also this array of points or circles. So those would represent the embedding vector, which are actually the elements that are saved in a vector database. And I'm going to explain you this now in the next diagram. All right, so we have already seen how we extract memories from the recent conversation. So more or less we have understand how it's done, but we still don't know very well what is an embedding vector or an embedding. And now I'm going to explain you how we inject relevant memories. We actually do this thing by using this framework or this concept called retrieval augmented generation. And by explaining you this, along the way, I'm going to explain you, and you're going to understand super well what is an embedding, what is an embedding model, what is semantic search, and what is a vector database. So let's get started. So retrieval augmented generation is a 3-word concept. And as a 3-word concept, I want you to understand it as a 3-step process. So first of all, retrieve, second, augment, and third, generate. And let's start now by, of course, number 1, retrieve. So what happens when Ava gives you an answer is injecting some relevant memories before giving you the answer, right? So those memories will be injected, let's say, in the prompt. So those memories that we retrieve are the result of doing something called semantic search. And now let's go step by step to understand how we do this semantic search and what it actually represents, what it actually means. So first of all, we have just a query or a question or just a sentence that is just a string, right? It's just plain text. So what we do is we use an embedding model to generate an embedding or an embedding vector, which is simply a vector representation of an object, text, image, video, or audio. And by vector representation, we just say numerical representation, right? As we have it here, it could be something like 0.5, 0.4, 0.8, 0.1. And usually, of course, in a higher dimensionality than just 4, but essentially it's just that, right? It's just a vector, so a numerical vector. So what is an embedding model then? So an embedding model is a model that converts those objects into meaningful vector representations. And here let's pay attention to meaningful. And by meaningful, let's understand it from the text perspective. So it has a semantic meaning, right? And this concept of semantic meaning ties very well with the next thing, which is semantic search. So semantic search is just doing kind of like nearest neighbors for vector representations. And nearest neighbor, if you don't know, is a technique to find those close elements in regards to a distance. And finally, last thing from this list, what is a vector database then? So a vector database is also called like a vector search engine. And that what it does is it manages, so it helps you indexing, retrieving, and querying these embedding vectors. And since I know this might still not be completely clear, let's zoom in what a vector database is. Right? So a vector database would store these high-dimensional vectors, but now for the sake of this explanation, let's just imagine that we have just 2 dimensions. And what I have here represented in green are those relevant memories that we have already extracted in past conversations with the user. And in blue, we have that query for which we are doing the semantic search. So what we are actually doing is finding in this high-dimensional space, so here in this simplified version, in this 2-dimensional space, those vectors that are the closest to the query. So here the query was that I could be asking Ava, right? So I could be saying, hey, remember my favorite movie? And Ava, before giving an answer, it will look into her long-term memory, into the vector database, and it would retrieve those relevant memories. So what could be those? Those that have a similar semantic meaning. So let's just look at this sentence, right? We have remember my favorite movie. So what are the things here that have semantic weight? So that would be, for example, remembering, favorite, or movie, right? So here we can see on movie. movie and film are semantically close because those represent the same thing. And similarly, as well here, movie and movie, of course, that's even clear. And those things are, so these vectors are very close by because they are talking essentially about the same thing, movies. So this way you could imagine also different clusters or different agrupations forming by different topics. So another topic could be something about food. So we have here that Ava has stored in her memory that the user loves pizza and also he likes to eat healthy. Could be contradicting, but here those things are about eating, right? So they are close by in the vector space. Same thing, he's from Lanzarote, he lives in Madrid. So these things could be related to a space or to cities, and those things are more so these two things have more things in common than pizza and Lanzarote. So this more or less would be the whole idea of semantic search. I hope you understood it, and if you didn't understand it, please drop me a comment below and I'll try to explain it myself. So I'll try to give you more examples, and maybe I can even just send you a couple of articles that explain this as well. So with that, we have understood the first column or the first part, the retrieve part, which is actually the only complicated part because the augment and generate parts are very simple. You'll see. So by augment, what we mean is just that once we have retrieved this memory, so the closest one was his favorite movie is Ex Machina, we are going to inject that in the prompt along with the current conversation and those system instructions that Ava or the agent is following. And finally, once we have this complete prompt, what we do is just to invoke a large language model. In our case, in the case of Ava, we are using Llama 3.3 via Grok, and we just invoke this model to generate an answer. And the answer could be something like Ex Machina, right? So this shows how we use this framework, RAG, Retrieval Augmented Generation, to inject the relevant memories into Ava's brain. So let's review that again, right? So we take a query like remember my favorite movie. We use an embedding model to generate an embedding. And then we use a technique called semantic search to look in the vector database for those embeddings that are similar semantically. We extract those or we retrieve those. In this case, could be something like his favorite movie is Ex Machina. Then we augment, right? We inject this into the prompt. And then we use now with all this information, we call a LLM model to give you an answer, which is something like Ex Machina, right? Awesome. So this would more or less represent a retrieval augmented generation, right? But there are other advanced things that I want to just quickly mention, right? Which is this thing or this word called chunking that you might have heard before. And the whole idea of chunking is that so in this case, in the case of memories, we usually have short sentences or short messages. But what happens when you want to create a vector database based on books, for example, or long pieces of text? So the whole idea is that you have to divide or chunk those long texts into shorter chunks. So that would be chunking. And also an embedding model, right? So in the same way that we have a model for generation, we also have a model for embedding. And here you should select an embedding model depending on more or less depending on that meaningful representation that you want to get from the data, right? So an example could be, for example, if you are talking in a very specific language, right? If you're talking in English, then it's simple, but maybe in Spanish, there are models that work better than others. So you would maybe use an embedding model that is better for only Spanish or for a multilingual application. So that could be an example. Another example could be if you are building a RAG for a very specific domain, for example, biology or chemistry, right? So where you have all these technical words, and maybe if you use a generic embedding model, those would be diluted. So you want a model that is able to find that meaningful representation between those sentences and terms. And if you want a more detailed video about these advanced techniques and just RAG in general, just let me know in the comments and I'll make it. And now a very quick overview of vector database providers. So as in the past lesson, there are many to choose from. So in the past lesson, it was Agentic Frameworks. Now we have vector databases, right? So there are plenty. I think I listed more or less the ones that I know, but I believe there are a couple more. And again, as with the agentic frameworks, you shouldn't be using them all. Just choose the one that you like and just go for it, because they all perform very similarly, because they are all kind of like competing among themselves. The things that you want to maybe be paying attention would be like the speed of the semantic search, of this retrieval. But I think more or less they are all equally fast. But I'm going to tell you why we chose Qdrant over the other ones. I myself have used Chroma in a lot of projects, but yeah, for this project we use Qdrant for 3 reasons. So the first reason that is actually quite important for me is just that it's open source. I like when projects are open source. Qdrant it is. Secondly, you can self-host it, so that means that you don't actually need to pay for it. So you can integrate that in your own server, in your cluster, or in whatever you want. And they have also a nice Docker image for you to do it simply. And finally, because of their free tier in the cloud option, so they have a cloud-based option to use Qdrant, and they have a free tier powered by Google Cloud, which is very convenient. So you just need to get an API key and just install a pip library, and everything works. And that's really a nice user experience, or a nice developer experience. And at the end of this video, I'm going to show you how you can get that API key and how the Qdrant cloud looks like, which is very simple. Okay, and let's now have a quick look at the code. And I think by really analyzing a couple of things that we have here written, everything will make a lot of sense. And I promise you, it is quite simple. So as for the short-term memory, I don't know if you remember in the first diagram that we saw in this lesson, we had on the left side hand the memory, right? And I told you that we had that what we do is essentially just writing down the graph state in local list, let's say, by using SQLite. And the graph state was this set of parameters: the summary, the workflow, the audio buffer. So this is represented by the class AI companion state that you have in the code, which, by the way, just remember that you can access this code by looking at the repo that I have linked below in the description. Everything is completely open source, and you can have access to the entire application right now. So in order to persist this graph state in memory, which contains all those recent messages and so on, what we use is this async SQLite saver, and we use this as a short-term memory, right? And just essentially, as I said, we are storing this right now locally, right? You could store this in a Postgres SQL or whatever, but just for the sake of this project, we have decided to store it in memory. And yeah, essentially, we just have this SQLite database living here. And by using this, we can recover those conversations or those recent messages or that graph state. So what you have to do then is just use this checkpointer parameter when you compile the graph, and you give that short-term memory, and that would be all. Quite simple, as I said. And now for the long-term memory, remember that graph diagram in which we had the brain? We had those 2 nodes. We had the memory extraction node, in which we extract those relevant pieces of information from the conversation, and also the memory injection node, which what it does essentially is this retrieval augmented generation framework. So let's look first at the memory extraction node. What we do is we just get this object that we have created called memory manager, and what we do is just extract and store those memories, and we just pass that last message. And if you look at the code, you will see it better, but let me just jump into the most important thing, which is maybe the prompt, right? So we have this method, analyze memory, in which we create a prompt, and then we invoke a message on that prompt. And what we want to do is that the output of this invocation should be kind of like a memory analysis, just saying, is this message important, and how the message should be formatted to be stored, right? And this goes along with the prompt. And the prompt essentially does what I told you in the very beginning of this video, which is to instruct the model on doing what I told you in the beginning, which is more or less what ChatGPT does, which is to understand if there are important facts mentioned in the message, things about personal details, so the name, the profession, what are the preferences, life circumstances. So those things that are important will be saved as a memory. So things that are important, for example, would be something like a message like "How are you?" "How are you?" doesn't convey or doesn't have any relevant information. So that would be discarded by this kind of prompt. And then what we have is the memory injection node that what it does is the retrieval of those memories and then the injection, right? So we are still not doing here the generation, but we are using the memory manager to get those relevant memories by using the vector database, and then we are returning this as the graph, right? So this is kind of like the augmenting, because now we have this context, and it is then at the final stage when we use the conversation node to generate an answer that the memory context is used. And we can quickly review that prompt, which is this one, in which you can see how, as part of the whole system instructions and so on, we give this, right? We give the memory context as the user background. So here is where we will put all those memories that are relevant to answer that specific query. And for retrieving, we have this method, get relevant memories, which uses the vector store or vector database to search for those memories. And the search in itself is just using Qdrant's client to search over a collection, and a collection is just as a table, let's say in SQL. So this would be more or less where you collect your different embeddings. And it's of course this search method, the one that does this semantic search using the query embedding, right? The embedding of the query. So we have to use an embedding model to encode that query. And once we have that, we also say how many K, right? So remember, like this nearest neighbor. So how many of those closed vectors we want to retrieve. And for this whole thing to work using Qdrant Cloud, the only thing that you have to do is just use the Qdrant client, which is, again, it comes as a Python library, and you just need to give the Qdrant URL and the Qdrant API key that I'm going to show you right now how you can get it. So here we have Qdrant Cloud, when you are going to be able to see all your clusters. And as I said in the beginning, you have a free cluster powered by Google Cloud. And yeah, you can just create it by just clicking create. Here right now, I cannot create it because I have already one. But once you create it, you just give it a name. And once you have that name, you're going to be able to access the database by opening the dashboard here. And this is going to show you all the collections that you have. So for example, we have the collection long-term memory, of course, for this project. And we have different things, right? For example, I have things that Ava has gotten from my conversation. So he's from Lanzarote, the Canary Islands, but lives in Madrid. In this case, it would be he, but the whole idea of my message, maybe my conversation with Ava, was that I like to do CrossFit. So Ava got, okay, he enjoys CrossFit, because it's something important that maybe she will remember a couple messages later when we talk about sports. And here as well, another thing you can see is just all the other metadata that you have along this vector would be, for example, the timestamp or the length of the vector itself. And finally, as I said, you just need to set this up by just getting an API key and just setting the URL, and that's it, right? So you create an API key by just clicking here, create. I already have one. And then you also use the endpoint or the Qdrant URL, and that's it. You set that up as an environment variable and you are all set. So that concluded lesson 3. I hope you enjoyed the video, and if you did, just please give it a like, and also subscribe to my YouTube channel and hit the notification bell if you want to be notified when we upload the next lesson, which should be next week. Bye bye.